Hello everyone, my name is Jakob DeVos, and with Dr. Sue Chin Cho, my research is on escape from adaptive conflict in the human alpha-amylase gene family. So, what is human alpha-amylase? Well, alpha-amylase is a protein that catalyzes the breakdown of starch for further digestion. So what you're looking at is the brief evolutionary history over millions of years of this original amylase gene, and as we can see, there are two duplication events resulting in three general proteins which we are looking at today: AME2B and 2A, which are produced in the pancreas, and AME1, which is produced in the saliva. So, the reason these gene duplication events in that evolutionary history is important is because now we have three separate genes, one of which is in a pretty acidic environment when it enters the stomach acid, and the other of which is in a slightly basic environment with AME2A and 2B being produced in the pancreatic juices. So what these gene duplication events have done is allowed the gene to escape from adaptive conflict, whereas one gene likely wouldn't have been able to mutate in a way that AME1A can survive in the stomach acid and AME2A and 2B can survive in the pancreatic juices. So because of this, we are going to test how well these proteins function at different pH levels to confirm that AME1 does indeed function better at lower pH levels and AME2A and 2B function better at higher pH levels. So, to do this, we are calculating the protein activity by finding the amount of maltose released through a colorimetric protein assay, which just means that we are putting in dilutions of the protein with a starch solution, letting it sit for a bit and break down the starch, and then calculating the protein activity from how much maltose was released from the broken down starch. And after finding these baseline values, we can then change the pH levels of the starch solutions and then find the data we need to test our hypothesis. So this leads us to our end results at a current time, in which we have done pH ranges 8 to 2. So as we can see here, the highest activity level for most of the proteins is around pH 7.5 to 7. Whereas we can see as we get into lower pH levels, it is pretty clear that AME1 does maintain that relatively higher level of protein activity compared to 2A and especially compared to 2B. So in the future, we are going to continue looking at higher pH levels up to pH of 11 or 12 and see how well AME2A and 2B hold up compared to AME1. And this is important as understanding the evolutionary mechanisms that allow us to evolve from our ancestors millions of years ago is important to understanding how we might evolve in the future and for understanding how the genes we have now have come to be.